All right, we're going to take a look here at lesson 51, properties of isosceles and equilateral triangles. Now, you guys know what these are. Isosceles, meaning that we have two sides are the same. Equilateral, meaning that we have all three sides the same. Okay. Now, there are always going to be some relationships with those. If we have two sides that are the same, the angles opposite them are going to be the same. Okay. So, what we're looking at here are these two theorems to begin with. If a triangle is isosceles, then its base angles are congruent. Now, when they identify base angles, this is on the bottom here, these angles here, so it would be that M and N are going to be congruent. Also, the other one that's part of this here, if a triangle is equilateral, it is also equal angular. So I'm going to give you a few moments here so that you can get those two things copied down into your little book. Okay, so here we go. So if I want to prove that this isosceles triangle is going to be congruent and prove or say is an isosceles triangle, what we're going to need to do here is use the information, make sure that this actually plays out correctly. Now it tells us that ABC is an isosceles triangle with AB and AC congruent. D is the midpoint of BC. Okay? So what we want to do is prove that angle B is congruent to angle C. How can I do that? Well, as we've been working through these things, you should see that by breaking this up, drawing the altitude down, this would be a right angle in here, correct? So this side and that side are congruent, correct? That side and that side are congruent by definition of midpoint. And is AD congruent to itself? Okay. So we've got everything that we need there. So we got written down here, we've got AB is that, so we know that BD is going to be congruent to CD because of definition of midpoint, right? Okay. And AD is going to be congruent to AD because it's called what? Reflexive. So that means that triangle AED is going to be congruent to triangle ACD by what? Which one of those three-letter ones that I just used here to say that these two triangles are congruent? Side, side, side. Okay. So that leaves us with angle B is going to be congruent to angle C. All that's corresponding parts of congruent triangles are congruent. C, P, C, T, C. So we had the picture. We drew in the extra line to make two triangles, identified these triangles as being congruent, and we can go through and identify the parts as being congruent. The more you do these, the more obvious these things become. So I'm going to give you a few moments here and put these in here because these thoughts and ideas go with the last one. Again, if you read through these things and you think about what you know about an isosceles triangle and equilateral triangles, this makes sense. If two angles of a triangle are congruent, then the opposite sides are also going to be congruent. One of the things that you know about an isosceles triangle. Again, if all the angles are congruent, then it has to be equilateral. So they go back and forth like that. So what I want to do is be able to use these ideas to go and answer the questions. Now I've got triangle DEF as isosceles. So let's go through and make ourselves a triangle DEF. Okay. Now it says its vertex is at angle E. So that does tell us that we've got this side and this side should be congruent. Okay. This is going to be D. We have E over here, and this is going to be F. So, let's fill in the blanks. We know that D here is 36 degrees. Well, if D is 36 degrees, that should be congruent to that, so what should F be? 36 degrees. So, 36 and 36 adds up to what? 72. So we've got 72 degrees total so far. And how many degrees are in a triangle? So that means 180. So what is the measure of angle E then is, you said it, 108, right? Now is when the 108 comes in. 108 degrees. Okay. Now here it says the perimeter of GHJ is 12 inches. Now it says angle G is congruent to angle H and GH is 5 inches. So again, we need to go through and draw this out. Now let's see, if I put G down here and I put H down here, these two are supposed to be congruent. So if those are congruent, that side and that side is congruent, then that means that this here must be J. Okay. Now it says that GH is 5. Okay. Now the entire perimeter was 12 inches, correct? So if I got 12, I take off the 5, that means I am left at 7. So what does the measure of the other two sides have to be? 3.5, because they're equal. So 3.5 here, 3.5 here. Okay. So what I'm going to do here is I'm going to give you a few moments, and I want you to go through and do this problem. Once you got your answers, please type them in and submit them. Let's see. 72s and 36s. I see a 54 in there, but I see mostly 72 and 36. Okay, so let's give this a try and see what we come up with. Well, since we know that we are told that this is isosceles, this one over here has to be 72 degrees, correct? That's the only thing it can be. So if I add these two together, that gives me 144. So I have 180 minus 144. That leaves me with the 36. Good. So take care of this one. I'll give you a few minutes to work on that, and then I'll put the answer. Put it up just so that you can answer the questions. All righty, let's see what we got here. We got 4.5, 4.45, 2.3, looks like more common answer, 2.3, yep, and 3.15. So let's see what we got. Now, when in doubt, draw it out. So you can see what it is that you have to work with. We've got X, Y, Z. Now they tell us the perimeter is 15.2. So we know we've got that to start with. It says angle X is congruent to angle Z. So those two are congruent. That means that these two sides are congruent. So X to Y, 6.3. That means Y to Z has to be what? 6.3. So if I add 6.3 and 6.3, that means I end up with 12.6. So if I subtract off 12.6, that's going to give me 0.6 here, right? Yes? Doesn't that go to 4? 2.6? Is that what it's supposed to be? Okay. So, what, did I do something wrong? Oh, I know. Yeah. But for those of you that got it wrong, did you draw it out? See, that's the biggest problem. When you've got situations like this, draw it out, put the stuff in there. I mean, what work I showed there really wasn't all that much, but it goes and identify what goes where. So, give you one more here to play with. So, let's see, we take a look at this. I see 80, 80, 80, 90, 80, 90. Okay, 6.6. Now, the question what was coming up in the discussion is, well, you can put the triangle on any side and call it the base. This is true. How? Yes, each one of these is a vertex, but when we are talking about an isosceles triangle, there are certain characteristics of it that need to be identified in certain ways. Base angles. The two base angles are always going to be opposite sides that are congruent. So when we use this idea of the base, yeah, it's sitting on this. I could have it sitting on this side or sitting on that side. It would work just as well. But when we're talking in isosceles, base angles have to be opposite these. The vertex is going to be identified as there. Yes, those are both all three vertices on it. But the vertex angle is one that's by itself. The base angles are identical. So if the vertex is supposed to be 20 degrees, so it's 180 minus 20, which gives us 160. Divide that by 2, and we end up with 80 here and 80 here. Okay. So, be nice. So, it says a triangle is equiangular and has a perimeter of 22.5. Determine the length of each side. So, I got my triangle here. Again, we don't care about if the triangle comes out perfect. We just want to be able to identify the bits and pieces. Now it says it's equiangular. So that means this side is the angle is the same as this angle, which is the same as this angle. That means that all the sides are the same. So if it has a perimeter of 22.5, what would I divide that by in order to figure out what it is? Well, perimeter, how many sides are there? 3, so that means I'd have to divide this by 3. So that means I'd end up with what? 7.5? So that means each one of these sides has a length of 7.5. But again, it's knowing what is what given the information. So I'm going to give you a few moments here. Take care of this one. Okay. Okay. 2.2, 2.2, 2.3, 2.1, or 2.3 repeating. Okay. Oh, 21. So, triangle. Okay. Equiangular. Perimeter is 7 feet. So the sides may be all the same, but they're not all 7. So that means that this is going to be 7 divided by 3. Now, those of you that enjoy using your calculators, that's a great thing. But the problem is, this answer is most appropriately written as 2 1/3. Okay? 2.3 repeating is acceptable, but in a lot of instances, when you get a fraction, you are not going to be able to identify a repeating part of it, and you'll end up having to round. One of the things that you are going to have to learn to do in mathematics is precision. We are going to have exact values. When you guys get back to me next year or in 2 years, and we start dealing with some trigonometry, we have to be working with exact values. So please keep those things in mind. Now, there's a couple of more theorems for you to write down. Give you a few moments to take care of that. All right. If you were to really go and take a look at isosceles triangles, and work with them a little bit more, you'd understand these characteristics of it. These are just simply the theorems that state these in a specific way, if then. So, if I want to prove theorem 5-1, I am given that triangle ABC is isosceles, and it says AD bisects angle A. I need to prove that it is the perpendicular bisector of BC when it comes for AD. Okay, now, if this tells me that it's bisected, okay, angle BAD is going to be congruent to angle CAD. Would you agree with that? Yes, there's two triangles there, but what I'm talking about right now is simply the angle that is right here and right there. I want to establish the fact that those two are going to be congruent, and the reason that they're going to be congruent is because angle A is bisected. So that's by definition of angle bisector. Okay. Now, we are also told that this angle here and this angle here have to be the same. Why? Because this is going to be an isosceles triangle. So angle B has to be congruent to angle C because that's definition of isosceles triangle. So my question is, are these two congruent? Is triangle ABD congruent to triangle, what? The other one, triangle ACD, and why? Why are those two triangles congruent? Yep. We've got angle, side, angle, side, angle. So that means that BD is going to be congruent to DC simply because of corresponding parts of congruent triangles are congruent. So now I know that these two here are going to be the same. Now, if I've got an isosceles triangle, this segment is divided up into two pieces. That must mean that, oops, sorry, back down here a little bit, that AD, oops, bisects BC, correct? Yes? Okay. So that means, and that's what, definition of bisector? Now my question for you is though, does it have to be perpendicular? Why? As long as it cuts it in half, okay, you're correct. But I have to have this angle here, angle ADB and angle ADC. They would have to be the same, correct? Since these two angles must be the same and they must add up to how many degrees? 180 because they are supplementary. That must mean it has to be perpendicular, correct? So what we've got here is since angle ADB plus angle ADC must be equal to 180 degrees, and angle ADB must be congruent to angle ADC because of CPCTC, we can say that AD then is the perpendicular bisector of BC. Okay? So just because we were able to bisect it and say that the segments were the same does not necessarily mean that it was coming in at a right angle. By taking a look at the angles, then we were able to do that. So take a look at this one. We're supposed to go through and write a paragraph proof out that this is going to be the case, that triangle ABC is isosceles and AD is the perpendicular bisector of it. So if we can draw out that triangle, you will end up seeing that that is going to be the case. So we got that. Those are going to be the same. This has to be A, that has to be D. This is at a right angle down here. We know this side is the same as that. Okay? And there we go. Assignment is going to be due at the end of class on Thursday.